Welcome back to Workplace 30. We are starting on Chapter 4, but before we get started, there's a few basic things we need to go over. So the first of those is converting a percent to a decimal. So remember that a percent, if we divide it by 100, will give us a decimal. So we take our decimal, we move it 2 places, so this would give us 0.65 as a decimal. So go ahead and let's try the rest of those. Right, then you can check the answers with what I have on the board. Next, we need to be able to take the percentage of a number. So 35% of 2,795, we're going to change 35% into a decimal, so 0.35, and then multiply the two together to get our answer. Go ahead, give me an answer. So 0.35 times 2,795 is 978.25. Perfect. So try the rest like that. So you can check your answers with what we have on the board. Next, we're going to convert between percent, decimal, and a fraction. So, for example, 100% as a decimal is 1.00, and as a fraction would be 100 over 100, or 1 over 1. Let's try one as a fraction because we haven't been doing a lot with fractions. So to figure out a fraction as a decimal, you can use your calculator. You could go 1 divided by 25. And what do you get as a decimal? Pardon? 0.04. Okay. Then as a percent, we times this number by 100, so we get 4%. Okay, so go ahead and fill out the rest of that chart. Then you can check your answers on the board. Note that sometimes, like in this example right here, you have 3 decimal places, which puts your fraction over 1,000, because there's 3 zeros in 1,000 and 3 decimal places. Other thing you need to be able to do is cross multiply. Pretty sure we're all good at this, but we're just going to try one together. So to cross multiply, you cross the bottom to the top at the other side, the bottom to the top at the other side. So you're going to get 15x equals 3 times 75. Then, pardon? We're going to divide both sides by 15. So we get x equals this number, which turns out to be 15. Try the next two on your own. And then once again, you can check your answers on the board. Just make sure you've got what I've got. So we're going to start then with our section 4.1. Start by reading Math on the Job on page 148, and we'll answer the following questions. So here's some of your answers that you should have. For the rural areas, you could have estimated about 1850 or 900 approximately. For urban areas, it averaged 480 a year, which divided by 12 would be about 40 fires per month. Now, some reasons that there could be a change in the Winnipeg data. You'll notice that the data is decreasing, or that the values of fires are going down, and some reasons why. Mitchell says that Winnipeg tends to get flooded. Kelsey says that people are becoming more aware. Kelsey's answer is what my answer key says. Mitchell's is a very good idea also. The effect that this has on insurance, Brianna says insurance might go down because of all the data that's been collected. So that's a very good answer also. Next, we're going to read Explore the Math on page 148 and fill out the following definitions. So the definitions you can grab from your textbook under Explore the Math, and please also write down this formula because we will be using it a lot in the next little while. So you can read through example 1 on page 149. Out of 265 light bulbs, 2 were defective. So first we want to express the probability of a light bulb being defective as a decimal, and then a percentage and a fraction, and in a written statement. So first, our probability of our event is the number defectives over the total. So the number defective is 2. The total is 265, which gives us an answer in a decimal when you calculate that. 0.0075 is our decimal. Now we also want to write that as a percentage. So how can I write that as a percentage? Good. Equals 0.75%. And I'm going to ask you to write it as a decimal also, but when you're doing probabilities, it actually gives you, the fraction, as a fraction also. So this is your fraction given right there. Because in lowest terms, if you were to go, figure this out, you'd have to convert to lowest terms also, which would give you this in the end. So that's your fraction. So in a written statement, we can write 0.75% would be defective. So those are all the different ways that we can write this answer. Now, part B, in a shipment of 5,000, how many are likely to be defective? Now, we know that this is not an exact, but it's just based on the past experiences. So we know that 2 out of 265 are defective. So now we're trying to figure out how many out of 5,000 would be defective. So using this, we can just cross multiply, and approximately how many would be defective? We get approximately 38. Now there is another way of doing this. You could also take your decimal version of a percentage and times it by your total, which is 5,000. So you could have gone 0.0075 times 5,000, and that would also get you approximately 38. Either way is fine with me. So discuss the ideas. Weather forecasters consider past data and current conditions, and they use modeling software to analyze potential weather outcomes. Consider the following scenarios and make predictions based on the weather information. Philip is planning a fishing trip with his nephew on Saturday. So here is Saturday. It's a little bit small, but it's also provided bigger in your textbook. He wants to go on a day when the temperature is not below freezing. Based on this, what would you suggest Philip do and why? So if you consider the past data for Saturday, it seems like lots of the temperatures are above zero, so that should be okay. Here the temperature also is predicted to be above zero, but if you look at the wind, it says it's 25 kilometers an hour, which is, would make it pretty cold, or would make it feel like it's below freezing. So suggestion might be to move it to Friday, because Friday is sunny, 2 degrees, and only has 10 kilometer an hour wind. So I would suggest you move it to Friday. Mitchell says, what if he works? Then I guess you got to go Saturday. Now our next scenario is Mariah is fixing a roof on her mother's house. She knows that she'll have to replace some shingles and wants to do it on a dry day, so not a day that's going to rain. Do you think Saturday would be a good day to do repairs? Why or why not? So Saturday, it's right here. Picture shows sunny and a little bit of clouds, 12 degrees Celsius looks good, wind north 10 kilometers an hour, humidity 87%, and POP, that means probability of precipitation. I actually wrote that in here. Okay. It means the probability of precipitation. POP of 75% means that in 75 out of 100 similar cases, or similar weather situations, rain or snow has fallen. It is calculated for any point in the forecast. So that's actually interesting. I didn't realize, I always thought it was percentage of precipitation, not probability of precipitation. And I also didn't realize that they checked the other weather patterns and that's how they made these. So, looking at those, we know that POP is 40% that day, the probability of precipitation. What do you think? Okay, it's all right. It's less than 50, which makes it seem okay. But is there still a decent chance that it'll rain? Probably pretty good chance. Now, it would be up to you to make this decision whether you would take the risk or not. Brianna, would you take the risk? Yeah. Brianna said yes. Kelsey? Yeah. Kelsey said yes. Mitchell? Yeah. Mitchell said yes. Julius? Yeah. Yes. Okay, all my class would take the risk. I would not take the risk because I know how expensive it is to fix leaks, so I would not take the risk, but it would be up to you. So write something down to that effect. So it's okay to estimate, don't forget that. So you could write 10 over 40 reduces to 1 over 4, so about 0.25 or a 25% chance that it will be a warm home furnace. Okay, you then have an assignment, page 154, number 1 to 8 all. And if you look on your handout, There is question number 1 here on a chart, so you don't have to make the chart. So go ahead.